a quick introduction, very quick, because I'd like to get this handed over to JP, who is a BDA expert with Honeywell, and I know he is the one you were all here to hear and learn from. But hello and welcome, everyone. I see a lot of familiar names have joined us today. That is great. I look forward to getting to see each of you in person again here very soon, hopefully. I know we're at Absco. We're starting to get out more, starting to do more lunch and learns, more events like this in person and remote. So something for everyone to keep in mind. If you're looking for a little more personalized approach for your organization or your company, please do reach out. Can we go ahead and hit the first slide? Perfect. I think most of you know all about Absco Solutions, so I'm not going to spend a lot of time on this slide. But we are a plus 40-year-old company. We have been around for a while. We have offices throughout the Northwest, so we are able to serve the Northwest very, very well. We have offices in Linwood, Washington, Fife, Washington, Spokane, Washington, and our newest office is in Beaverton, Oregon. I think we've had brick and mortar there about four years now. So we're really able to cover Oregon and Washington very, very thoroughly. We've been partnered with Gamewell FCI for I think about 38 years, back when it was just FCI, before Honeywell and Gamewell and the merger and all that. We are very familiar with Gamewell FCI and all of their products, including BDA, which we're talking about today. We are your local facility vulnerability experts, and I was looking at this slide. If we can actually go back to that slide a little bit earlier, and I'm looking at the 6 people on the slide, and I was doing some quick math in my head. Those 6 people right there represent over 100 years of experience in this industry. Pretty amazing amongst 6 people. So when you need some assistance, you need some help with some AHJs or whatever it may be, that's what we do. We're here to serve and assist and help make the world a safer place, just like you are. We're always learning. We're always attending trainings as technologies are always always evolving. I know you are as well, and I thank you all for attending this. Probably worth noting as well. For those that need CEU credits, we are offering those through this presentation. So if you'd like to collect some CEU credits, please reach out to myself, Jen, or Liz after this webinar, and we'll make sure you get accredited for this. But if you're not familiar with your local account executive, please reach out. Let's get an in-person meeting set up. Let's figure out how we can work together, how we can make your lives easier. And most importantly, help save lives and your local communities. So with that said, I would like to turn it over, maybe I'll turn it over to Dan Moore first, local Honeywell Business Development Manager. We'll let Dan do a quick introduction, and then we'll turn it over to JP. Dan, take it away.
Yeah, thanks, Tom. My name's Dan Moore. I'm based out of Seattle, Washington. I'm the Business Development Manager for Gamewell FCI and Fahrenheit, and I've been with Honeywell for about 17 years, coming up next week, and just happy to support you guys locally. Anything you need, I often travel with the sales crew here, so if we need to come by and do a lunch and learn on BDA or anything else, I'm available. So I'd like to introduce JP. He's our Senior Business Development Manager, or I think more recently he's a Director of our BDA portfolio nationally, and he's based out of Florida. I'm happy to have him today doing this presentation. He's our industry expert. And JP, let's jump right into it. Maybe say a few words first, and we'll get right into it. Thanks.
Yeah, thanks, Dan. Yeah, I should have updated this here. Dan is correct. I recently have taken over the business. I'm now over both North and South America for the BDA business, pretty much from end to end now. So my background, guys, just to give you a little bit, been in the industry about 22 years as a life safety provider, very similar to Absco, actually. Right out of the military, started into the industry, worked my way all the way through. And a couple years ago, I decided to, leave a business I've been with for quite some time to run into the manufacturing side to run their business. Here in Florida, where I'm stationed, I'm based out of, it's a big BDA market, very similar to what Washington is. So I've been dealing with these systems personally probably for the past 5 years, almost dedicated at this. And now currently am running, this side of the business for Honeywell. What we want to go into today, look, I want you guys to be able to ask questions if you guys have questions throughout this. I want this to be interactive as best as possible. But we want to go through just kind of understanding what these systems are. I know we've got a mix of people that are on, this call today, everything from end users to the integrators or salespeople and or, our A&E group that is with us, architects and engineers. So let's jump into the code side of this. That turned off, and we'll run through the code side in the beginning. So where can we find this at? Well, we can find these, requirements for this in the IBC 2015 and 18 edition. You'll find that in section 9.16. Also in NFPA 1, section 11.10. You also find this in the IFC 2015 and 18, and in section 510 for that one. You guys will get a copy of this deck. Dan has got the availability to it and can send this out to you guys in a PDF format because there's a lot of codes here. We're not going to get through all these slides and everything here, but there's rough about 150 slides, and a lot of it's got a bunch of different state-driven, specifications, but also the codes throughout. Okay, so when did we really start seeing this? Look, it started showing up in the appendix back in 2009, and just so people know, the appendix is not really enforceable as where the body of the code is. So a lot of AHJs, they'll look at that more for a guidance side of it, but it moved from the appendix into the body of the code back in 2012, okay? Now, so 510 says, hey, look, we want you to talk about new buildings, but also this is retroactive for existing buildings, okay? So not all states are enforcing that, but the code does state, hey, in section 11, we want to look at that 1103.2 is specify the requirement for emergency responder coverage in the existing buildings. Same as we would for a new building. What other code books are we going to find this in? The NFPA 72, which is our fire alarm code book. You'll see that living in that code book in the 2010 and 2013 edition. Well, but when 2016 came around, we moved that out of that book into the new code book, the 1221. It's going to stay in 1221 for 2 years. Or two cycles, I should say, the 2016 and 2019. And after the 2019 edition, there's a new code book that's being developed right now, which is NFPA 1225. You will see that one in 2022. And currently, we're well over 35 states are requiring BDA systems across the United States right now. I would say we're probably closer to about 42 states are now actually requiring them in some form or fashion. So what does IFC 2018 say? Okay, so if you look at IFC 510.1, emergency responder radio coverage in new buildings. It says new buildings shall have an approved radio coverage for emergency responders within the building based upon the existing coverage levels of the public safety communication system of the jurisdiction. Measure the exterior of the building. Guys, what did that say? It says, hey, look, go outside to the building, take a reading, and based upon that reading outside is going to tell you whether or not you can go inside the building and do a survey. So again, what does that mean? If you don't have usable signal strength outside of your building, there's nothing for you to amplify inside of the building. Therefore, this will be your first exemption. So if you are in a rural area and that rural area has no usable signal strength whatsoever, that then would deem you as being exempt until they do have usable signal strength. Because unlike for you, this code is not meant to make the authority having jurisdiction, the municipality, the counties, the cities, upgrade their macro networks, okay? So next section, 510.2. So this says emergency responder radio coverage in existing buildings. Existing buildings shall be provided with approved radio coverage for emergency responders as required in Chapter 11, okay? So Chapter 11, 1103.2, emergency responder radio coverage in existing buildings. existing buildings other than group R3. So here's our second exemption. So group R3, that do not have approved radio coverage for emergency responders in buildings based on an existing radio coverage level of the public safety communication system shall be equipped with such coverage according to one of the following. Okay, well, it says, hey, whenever an existing wired communication system cannot be repaired or is being replaced, or are not approved in accordance with section 510.1 exception 1. What they talked about there is say, hey, look, we have got a fire warden system or a hardwired firefighter phone system. If that is being replaced or cannot be repaired, it needs to be put in with a wireless system. Or if exemption 1, meaning we don't have usable signal strength outside of that building. Next, we're saying, hey, within the time frame established by the authority having jurisdiction. Okay, next, signal strength, inbound. A minimum inbound signal strength sufficient to provide usable voice communications as specified by the AHJ shall be provided throughout the coverage area. The inbound signal level shall be sufficient enough to provide a minimum DAQ level 3 for analog or digital systems. What they're talking about here is saying, hey guys, we've got to have that signal strength that is strong enough to give us deliverable audio quality. It's a DAQ that says, hey, a 3.0. Now I'm going to tell you, this is what the code currently says. There's a lot of back and forth going into this piece of it because it's subjective. A lot of people are looking at what we call the SINAR, which is a signal to noise ratio. What we do is we take a signal reading, a minimum of -95 dBm inside that building, and we measure that against what the noise floor is outside. That's our signal to noise ratio. That's kind of going to tell us if we have a usable signal strength. But the same is required for the outbound. Whatever we have coming into the building has got to be equal to go out of the building. And when we think about that, we've got a big tower. That tower is shooting us a signal all the way down to the building. It penetrates the building. It's 150 watts. I pick it up on my little 3-watt radio. I now got to have enough signal strength to go all the way back to that tower on my little 3-watt radio. So that's why we talk about inbound and outbound signal strength. So where's our coverage requirements? Well, the coverage requirements, okay, we got to have 99% coverage in what we classify critical areas. By the way, this list right here is not a complete list. It is a list that the AHJs can deem to add and or subtract from, but this list right here is what they currently look at. In the newer revisions, you're going to see things like elevator shafts and or elevators and restrooms, stuff like that that are inside of, you know, public and commercial buildings. The non-critical areas of the building, okay, these should have 90% as required by NFPA 1221. But if you're dealing with IFC, it's going to say, hey, I want 95%. So most AHJs are using the 99 and 95%. That's two separate areas of the building. A non-critical area is deemed as an area that would be, say, your residential unit, an office, anything other than what is classified as critical. All right, some future code changes that are coming that we want people to be aware of when you guys are looking at systems. Okay, there is a UL 2524. That UL standard is a life safety standard that was developed back in 2012, 2013 timeframe to say, hey, look, you know, we need these systems to be established, okay, to meet a life safety standard base across the board. So now all the code officials and groups through ICC, so we've got IFC, IBC, NFPA1, they all are going to be requiring all systems to be UL 2524. I know a lot of people a few years back said, hey, Honeywell is the only one that's got the UL system. Nope, they were right then. They're no longer right with that statement anymore. Most of our, you know, competitors, you know, and fellow people in the industry, they all have caught up to that. Okay, so there's roughly there's 8 brands and 5 manufacturers that all have UL 2524. So there's plenty of people in the market out there that have it. It's also why all the code committees say, hey, we're going to require it being. This battle card right here is good for everybody. This gives you all the different code books, the years, and what the different code requirements are. Kind of will tell you where it is. Hey, platinum rated coax cable, where do you find that? Well, you can find it in these sections of the code. Okay, so you guys will get this with this battle card. So let's talk about this. What is a BDA system? Well, to start with, during an emergency, reliable communication is critical for all first responders. I want everyone to see that right there. NFPA 1 says fire department. That's being changed to first responders. public safety, because all first responders who enter a building need to be able to have appropriate communication at all times. Whether they're going in there as a group or as a singular entity, they need to be able to communicate. You need to put yourself in a situation where a first responder walks in, maybe they're having to administer medical help to somebody. They go down to grab their radio to call out, and unfortunately their radio can't call out. So that's why the BDA systems and the codes were implemented and put into effect back in 2002. That was following 9/11. So 2002, there was a call to action saying, hey, listen, we've got an issue here. There are so many buildings out here. There's over 5.6 million commercial buildings, and they're saying, hey, 85% of these buildings currently we are having some sort of signal loss or issue throughout. So I said, so how do we rectify that issue? How do we correct that? Well, that system is solved by using a BDA, which is now part of the public safety system. Someone got a question? Whoever is on clicking, if you could go on mute, that'd be great. So a BDA is a life safety system. The system has got to be supervised by the building fire alarm system. They are typically purchased now with the fire alarm system. They're installed and tested by qualified factory certified technicians, and they are inspected by the AHJ. There's code-driven requirements that are requiring these systems to be installed. There are also AHJ specifications. I will tell you that that King County area that a lot of you guys are probably familiar with, it probably is one of the most established specifications in the country. They know what they're doing there. They know what they want. They want Class A channelized systems to be installed, and there's reasons for that. Okay, and we'll talk about those a little bit more. But the BDA system, when people think about that, it is a life safety system, very similar to your fire alarm system. So what is it? The bidirectional amplification system that's used to enhance in-building radio coverage signal. Okay, when we look at this and we say, okay, hey, why or where would I need this? If I said you're walking around a building and your cell phone cuts out, you then would say, I need a better system, or I need a better tower or something, or you could put in a BDA, which in reality could amplify a cell signal if it was on the same frequency band. So this amplifier, it will take a signal from outside of the building and it'll shoot it towards the building to the donor antenna. That donor antenna will bring it into an amplifier that will distribute it throughout the affected area that is having poor or limited coverage within it. So that radio frequency amplifier that will amplify and boost the signals in two directions. It allows you to receive and also send. The distributed antenna system, which is inside the building, known as a DAS, an active DAS BDA signal booster, and an antenna distributed, provides coverage in the building within the structure. Here's just more of a blown up view of this. Again, your typical radio tower, we call them a macro or donor site. It's got a coverage area. It sends a signal out. If the building, and we show in this section over here, this portion of the building was failing, a donor antenna on top would receive that signal and bring it down. Now, a lot of you guys have seen systems like this. You don't even realize it. The old television sets, we had poor fuzzy pictures coming in. What did we do? We went and put an antenna right up on the building, up on the roof. We ran a cable down and we plugged it into the television, and you turned it until the fuzzy picture went away. Kind of the same thing. We're gonna pick up that signal and send it inside the building. But what does this really look like? For those of you that are engineers, or those of you that have been in the fire industry for a long time, you guys have actually seen a similar system that's been installed in most of these buildings already, okay? So if I look at this right now, we're looking at a typical in-building DAS system, the donor site, the BDA with the donor antenna on the roof. Here's my riser going up and down, and these are my branch lines that are going out onto the floors. These are my little DAS antennas and my radio. What does that look like? It's your fire sprinkler system. Very similar structure and layout, okay? It's gonna go through the center of the building. You're gonna have your branch lines, okay? This is just an easy way to kind of visualize to see what this is. Now, you're not gonna need all the same amount of heads versus antennas that you would need. A sprinkler head every, 11 to 15 foot coverage, depending if it's an extended coverage. each DAS antenna, we can get about 7,800, square feet out of that. Gives about a diameter, about 88-foot diameter circle versus that 11. So what are the parts of the system? Okay, well, you're going to have your BDA, which is sitting here on the right. You have your battery backup unit. You're going to have an annunciator to it. Okay, each one of these systems are connected directly to the fire alarm system. They're in NEMA enclosures. Okay, they've got very large batteries that are going to give you 12 to 24 hours of constant backup. And again, everything is going to be a listed assembly. The code officials are starting to get really big on this. I was just at an SBC code meeting earlier today, and one of the things that they're starting to see throughout the states are, look, if you have a BDA system and you're putting a battery backup unit, it needs to be listed with it. We call it device compatibility listing. Okay, you just can't pair two of them off the shelf together because they've not been listed. So when you guys are looking at the systems, you want a listed group and an assembly. The BDU and annunciator need to be listed for their intended use with that system. What are the other components we're going to see in this system? Well, these components in these systems, guys, we're going to have these couplers, we're going to have connectors, we're going to have antennas, these splitters and couplers. This is very similar to kind of like your cable TV splitter. It's just going to split that signal out there. They're going to bring it down in one, connection right here, and they can split it out 4 different ways. A coupler, it's going to limit the amount of signal strength that's coming in and out through it before it puts it out to an antenna. The donor antenna is what's going to be affixed to the roof. That donor antenna has to be up there. It has to be on the edge of the building somewhere. Okay. You will see in the newer code coming out that they actually want it to be affixed to the building depending on the wind loads in that area. Me living in Florida here, our average wind during just a typical rainy day, we'll have 60 to 70 mile an hour winds, but we had a hurricane come through, I think a week ago here. They got up to, 70 to 75 to 80, but we've had them as high as, 150 here. So there's different wind load requirements for the antenna. So if you have an antenna on the roof, just need to make sure that it also meets the wind load requirements, okay? Because what happens is during a storm, we don't want this thing getting damaged or moving around, okay? We want that system, because what happens after a storm? First responders most likely have to go to buildings to rescue people inside them. We want them to be able to have proper communication inside there. Okay, the radio frequencies that are needed. This is an important piece of this, guys. The radio frequencies, you need to know what those are so that way people can actually do the site survey correctly and accurately. There's lots of different frequencies out there, but the AHJs are the ones who can specify and tell you exactly what is needed. When we talk about the AHJ, we have two different groups of AHJs. So what we have is we have the fire marshal, but then we have the license holder, or that he's the FCC license holder that works for the city, probably the city radio manager. They're going to be the ones ultimately going to say, hey, you need to be testing on these. But let me tell you that if we don't know what these bands are, look, 7,800, that's real simple for us to do. But if you have UHF or VHF, the cost delta between these not having the correct frequencies can be 4x. You could say MSRP is 25 grand for a BDA and a UHF if it's got the right frequencies that have got that 5 kilohertz spread between them. If they're what we call a simplex channel, that BDA could cost you $60,000. So make sure you have verified frequencies. It's one of the #1 things that we teach everybody, from the AHJs to the installers and even the end users. Make sure you have that, so that way you know that, hey, the people doing my survey know what the heck they're doing. All right, so what's the coverage problem? Why do we need all these systems? Why did I go through all that information on the code and what the systems are? Why would I need one of these? Why would I need to put it in my building? Well, the main thing is in-building radio signal degradation and attenuation. Okay, ultimately what it is the building materials attenuate or slow down or deflect that radio signal from coming in. Things like concrete, metal, other building materials that you may not even realize it, stucco and lathing on the outside of a building, low E glass. Guys, I will tell you right now, it's quite funny. If you have bad coverage on your cell phone, and if you happen to walk up to a window, you may think it's getting better. You're just getting closer to the signal, but the reality of it is, most windows that are low E, you have about a 30 dB signal attenuation. So what does that mean? that if I'm not standing in front of the glass, I have about a -70 signal strength, which is great. Well, if I walk in front of that glass and that glass now blocked, I have a -100, which is a horrible signal strength. So depending on how much low E glass is there. Here in Florida, not only do we have low E glass, we have stuff called turtle glass. For those that live close enough to the coast, you're required to have a green tint on your glass. So that way when the baby turtles hatch at night, they crawl towards the ocean looking for the moon and not towards your home. But the other thing we have is our impact glass. And then on top of that, like I have at my home, I have impact, low E, and a window film, because a good portion of my house is got west facing. Okay, and all of that deflects my signal strength. Okay, below ground structures. You guys have basements, I believe, there. We don't have below ground structures here in Florida. We call those swimming pools. Okay, so we don't have to worry about that. But if you have a below ground structure 100% of the time, you're going to need a BDA inside there, unless there's no building on top of it. Okay, other obstructions. These other obstructions could be other buildings in front of your building. They actually could be the topography changes, meaning high and low valleys, you know, within that geographical area. It could be billboards, it could be trees. All these things create attenuation. This is what causes BDAs to have to be put inside of buildings. So what's this kind of look like? Well, this representation on this slide here kind of shows you, I've got this large pipeline out here of signal. As it goes and it starts working its way from outside, as it works its way through the building, you notice it gets smaller and smaller. Now remember, on that one slide earlier, I said, hey, you've got to have signal strength adequate to get inside the building, okay? This was a big amount of power coming in. But now, I'm starting with a small amount of power, but I've got to go all the way back out. So in RF, we want to have a large enough pipeline inside of here so that way our radio can communicate the same path all the way out. If we don't have enough signal strength getting inside of the building, okay, we may be able to receive it, but you'll never be able to hear me. What does that kind of look like? Looks like this. You can kind of see how this is being depicted. We start off with a -68 out here, okay, at the building. We take that outer wall. We go through it. We just lost 20 dB. We're now seeing a -88. We go from that -88. We go through another wall. That's 10 dB of signal loss, and through that room, -98. We get right here. We go through another wall. By the time we get here, I want you to understand that public safety LMR radios, they can shut down between -110 and -120 and not work at all. Can they work at 110? Of course they can work. They can work at -98. They can work at -102. But remember, we work in life safety. Nothing we do is tested at the limit of failure. We find the limit of failure and we quantify what the safety means needs to be in it. That's where the -95 comes from. So now, what does this kind of look like within my building? So signal propagation, okay? This is now being depicted here. This is the propagation, the transmission of your radio signals. When radio signals encounter a physical obstruction, the signal is attenuated to a measurable extent, and some of the signals, is reflected away from the desired area. So that's one thing. Deflection is really big in what we deal with here because it'll bounce off of cars, it'll bounce off of materials in your building. If you have flat screen TVs, by the way, that's 100% attenuation. A lot of people don't realize that. Antique mirrors, tin ceilings, any sort of metal, it all reflects it out. But in the left-hand photo, okay, this is a heat map. This is a very large, wide open area. I want you to notice that this has got a very good, it's got a nice linear signal path throughout it. You don't see a lot of striations. You do see this orange getting blocked right here. It turns into a green or a yellow, then to the green and a little bit of blue. You can kind of see what happens when a wall comes here. It kind of reduces that signal strength. But the wide area, oh, that's awesome. This is about a 20,000 square foot area. To the right here, this is a hotel, my friends. This hotel, I want you to look at that magenta. That is amazing signal strength. But look at how close you start getting. You're less than 25 feet away, and all of a sudden you start having light green and light blues, okay? Beyond the light blue is going to be a dark blue, and that's a failure, okay? Let me explain something though. This right here is less than 7,800 square feet. This is 20,000 square feet. The better, the wider, the more open the area is, the better the signal strength is going to be. The more walls, the denser the walls and the materials within here, the more displaced and attenuated your signal is going to be. So we have coverage solution for multiple styles of buildings. I show this slide because a lot of people are in the misconception that BDAs are meant for high rises only. No, there's nowhere that says just high rises. I told you what the two exemptions were for these systems, okay? You're looking at either R3, which is a residential 1 and 2 family dwelling, or you're looking at a building that does not have any usable signal strength outside of it, okay? So we're looking at a 2-story. This is showing a school. This would be a mid-rise, and of course, high-rise buildings. So how do we figure this stuff out? When we know we need a BDA, because the code says, or that we possibly need one. We know what the components and what a BDA is and why we would need it, but how do we determine that? Well, we determine that by doing an RF site survey, okay? So this is a radio signal site survey. It determines if your building has sufficient radio coverage or if it needs a signal enhancement system, okay, which is an ERCES. Whose responsibility is it? Well, it's the building owner or the construction company to perform a site survey to certify signal coverage on a 100% completed building. Okay, survey reports need to be submitted to the HJ. So let's stop on that real quick. If we're doing a new construction project, for those of you doing a site survey in a new construction project, please understand that that construction project needs to be topped off, dried in, all doors and windows in, all partitions are in, all firewall are in, all the fire doors are in, and when you do your site survey, you need to ensure that that job site is shut down with all the doors and windows closed. If not, you are going to be having a false positive, okay, that the building is possibly passed, because as soon as you open up a gaping window or a door, all your signal is going to come in, okay? These signal strength surveys have to be done when the building is completely enclosed. Second thing I want you to take into consideration, you need to realize that you're doing it in an empty building, okay? So the AHJs are starting to get very acute to this, because a year after they did a site survey, they didn't need it. They go back a year later and all of a sudden they're saying, wait a minute, my signal in here stinks. What happened? Well, the building did not have any TVs up, had no furniture, had no people. It was not even occupied. So therefore, all of those elements, they add additional attenuation to it. So when doing a site survey on an empty new construction building, you're going to have a huge delta between what's actually being required, okay, to when the building is actually occupied. So for the building owners, a lot of times what's happening is they're saying, hey, let's go ahead and just put in our infrastructure. Infrastructure would just be a cable pathways, all right? Or they're saying, hey, actually put in my vertical cable and my horizontal cable inside that building. Because it's not an if I need the system, it's when I need the system. Unless you are a quarter mile, I'd say half mile max from a tower, eventually you're going to end up needing a system of some sort, okay, in a building. So the site survey, the HJ, he should have the site surveys done for all buildings in their jurisdiction. Doesn't mean that they need to have a system installed, but the more site surveys they have, the better off it is. And what do I mean? Okay, I've got a son who has special needs. Okay, he's got a very severe seizure disorder. He's also had a couple strokes. He works, he's gone to school, but if he goes to a location and he's stuck inside of a building and needs medical attention, and if they know that the building has poor radio coverage, when they go to dispatch an EMS unit to him, they're not going to send one, they're going to send 2 to 3. Why? Because they know they have poor coverage and they now need to have appropriate units there to relay the signal. Very similar to when they call out, it's a 1 alarm fire. I have 1 fire department going. 2 alarm fire, I have 2 stations going. 3 alarm. The more stations there, the more people we have, the better the chance are of us getting that, what we need immediately. This is why AHJs are saying, yeah, look, we may not force you to put one in, but we want a survey. The more buildings we know that have good coverage and bad coverage, the safer it is for the people residing in those buildings, but also for the first responders at the same time.
time is of the essence during any emergency response. Signal enhancement systems is required for buildings with insufficient coverage. Okay, that's what the code says. The AHJ is the one who will enforce that. Final survey signal coverage certificate is done upon building completion. All right, signals are done by an FCC JRL certified technicians, minimum 20 readings per floor, test on all critical areas. Here's an update. It was released today, Absco. I challenge you guys all. Dan will take you guys all out to dinner. Go on to NICET. Level 1 ERCES BDA technician is now available on NICET as of today. I was with the NICET team. They announced it today. So level 1 is there. They will be following up with a designer BDA option for NICET. Okay, that does not have to be, that's a separate course. Level 2 and 3 are to follow after the design comes out. So you can go get level 1 and also design at different, at the same time or different times. So that is coming out. You're going to start seeing AHJs requiring that. Secondly, they're still going to require FCC GROL. One of the reasons is if something were to happen with someone and they got their GROL license revoked, NICET will then revoke their NICET license also. So you're going to start seeing a lot of new requirements coming down for this. So I encourage everybody, Absco, you guys to be the first to go out there and get this. So how do we identify that coverage problem? Well, we're looking at a high-rise building. We're looking at a low-rise building here. We can kind of see what's going on. This section of the building here has got an issue. Just like if you guys are walking around the building, you know the dead spots in that building. Well, we're used to this. We saw this slide already. We're going to determine where our poor signal strength is inside of that building. Okay, so what benefits do RF site surveys do for my building or the jurisdiction? It gives you that physical report of the buildings with good and bad coverage. That data can be given to dispatchers, so that way all dispatchers and first responders are aware of the buildings of their communication level. Helps you understand and plan the pace of enforcement. Okay, remember, this is the same presentation we give to AHJs. Are they looking at a 12, 24, 36-month compliance? All right. We've all seen the old Frankenstein classic movies where all the villagers are coming down with pitchforks and, the torches, they're ready to burn them at the stake. Neither AHJ or companies like Absco or Honeywell want that for anybody that owns a building. So the enforcement and the pace of enforcement is being taken into consideration. The first step is getting the site survey done, though. Okay, being proactive is the way to be, because when we are reactive, okay, things ultimately are going to cost more. There's going to be higher deltas and also the possibility of AHJs getting more upset at us. So here in Florida, like I said, I've been doing this for about 5 years. We got a head start. A lot of our customers, we said, look, let's go ahead and just get these surveys done now. So that way when the AHJ comes, you have it done, ready to go, and you're being proactive. Secondly, if you have condo buildings, well, then you can plan accordingly with proper assessments to put it into the budget. I think Absco's got some guys on their teams that could definitely step up and help you guys start looking at some budgeting for these systems. It also helps identify non-permitted, non-UL systems. Why is that important? Look, these systems that have been installed that are out there that don't meet the requirements, okay, they are detrimental to the existing cellular and radio LMR networks. What do I mean? These systems, if they get out of control, they can shut down your cellular and radio networks for up to 3 miles. And I mean shut them down like you have a big jammer. And that's what happens when we have non-compliant systems. And secondly, it helps educate the building owners on what's going on in their buildings. So guys, there's plenty of code requirements that telling the building owners, telling the integrators what to do, but here's a section of the code that specifically tells the AHJs what they need to do. The AHJs, per this code, 9.614 says, hey, they shall maintain a document of technical information specific to its requirements, that it shall maintain the minimum of the following: the frequencies required, location, and effective radiant power of the radio sites, maximum propagation delay, list of specifically approved system components, and other supporting technical information. Look, if someone says, oh no, we can't do that, it's Department of Homeland Security information. Well, first of all, that's public information. Okay, that information is available through public sites, but the only and the number one, I said the best way for it to be validated is through the actual AHJ themselves. And for those of you that can hear in the background, I have my typical storms coming in this afternoon. You can probably see it's nice and dark behind me, and we've got 65-mile-an-hour winds with 0 visibility. So Dan, you may have to pick this up if I get cut off by a lightning strike again. Dan, please don't be asleep. So here's another battle card for you guys that kind of just, we put several of these in here so that way you guys can print them off. This just talks about the different requirements for in and outbound signal strength. RF site survey.
Back, JP.
What's that, Dan?
I got your back, JP. Don't worry.
All right, good. And this is typical in Florida this time of year, so we have these come through. This is what we call our lightning season. So where do we take these readings at? Where should we go? I already said the first place we go is we go outside the building. So Absco, if you're going to someone's building, first thing you want to do is take readings on all 4 corners of that building or all sides of the building, okay? And if you have no signal strength or unusable signal strength, since you have a building, the next place you go is on top of the roof. You go up to the roof to take that reading. FYI, Absco, if you guys have a building that does not have an accessible roof, you need to get some sort of means to get up to that roof to take a reading. Because depending on the size of the building, you could be getting over the obstructions. And it's not a if statement, it is a true statement that the higher up you go, the better off your signal is going to be, because you're going to clear your obstructions and or topography changes. Next, we go inside all non-critical areas. We need a minimum of 20 readings per floor evenly spaced out. We're going to look at some site surveys here in a second and see what it looks like. Then we have our critical areas. So building owners, A&Es, this is what a site survey, these are the 4 main steps you do for a site survey. So what would that look like for us? Here are some snippets taken from a site survey. So what should we expect? Now, this is the same material I use to teach AHJs on how to inspect site surveys. So you guys are looking at the answers to the test if you guys were ever required to pull permits to do site surveys, like they are here in Florida. Okay, they require them to do that. Why? Because it was a new requirement. They wanted to make sure everybody knew what they were doing, and the building owners were getting an accurate site survey. What do they look for? They want an aerial map taken from like Google Earth that depicts the building, the distance from the towers being ID'd, the distance to the backup, everything in life safety, but definitely in Florida, we have backup towers for backup towers. If one goes down, the other one, you can actually see 3 towers here that we're kind of dealing with. What other information? Closest communication tower. Okay, it's got how many miles away, the address. We've got the actual frequencies here. We have the FCC call sign. These are the type of things that people like to see on their site surveys. So we do a minimum of 20 non-critical readings per floor with a grid, no smaller than 20 by 20 and no larger than 80 by 80, you know, and separate readings in all critical areas. We go right here. So this would be my talk zone. Okay, so if I'm talking in this zone, this is where I'm going to take my reading from. Okay, so, and without relocating, must measure a 95 dB or greater signal level. What does that look like? I'm standing in the center of that. I'm looking at the direction my tower would be, so I need to know where my tower is at. I'm holding the radio directly in front of my face. Now, building owners, realize that there is a benefit to you guys because first responders wear the radio on their hips, and they don't care. We understand, though, that when we're doing a site survey, we want to give the most optimum testing, you know, situation, not the most restrictive. So we're giving, you know, actually a little more benefit holding it right there in front so we get a good clear reading out of it. Okay. So this here, this is what a site survey could look like. This one has got a lot of information on it. Okay. They give the inspection notes. They're saying, hey, look, this indicates critical areas. I can see these double dotted lines. They're all double dotted showing our critical area. They give very clear indications by color. They say, hey, look, if you see anything in this on this survey that's gray or black, it fails. Well, that failed, that failed, that failed, that failed, those failed. All these grids are showing failures in them. Very simple. But what you see here is inbound signal for the 3 towers and outbound for the 3 towers. So they're showing all that information. Now, I know that a lot of the areas where you guys are at, you guys will just have the one reading in and outbound for the 1 tower there, okay? They also have on here, hey, look, all the critical areas passed. This is one of their stamps. Wasn't for this one here, but they said general areas fail. Significant BDA coverage is required. Very simple to read. Color code, gray and black fails. Very simple. Did I pass? Did I fail? This is what AHJs want to see. This is what the building owners want to see. Okay? They don't want to see some quantum physics, mathematics on here. They just want to see, did we pass or fail, and what do we have as far as signal strength. Here's another example of a site survey. This one here, this one was done out of California. This is done with a spectrum analyzer. It costs about $20,000, PCTEL machine. This thing does all kinds of stuff, okay? You add your grids in here for you automatically. You take your readings in here. It puts it into report format. Why am I showing you guys so many different types of site surveys? Because there's not a defined criteria for the format of site surveys yet within the code. So therefore, they can have 5, 6, 7, 8 different form factors. But what you're looking for is an evenly spaced grid, easily discernible pass or fail. Are they denoting my signal strengths? Are they showing me how many readings were taken? Are they giving me, you know, that in a discernible pattern or format? Yes, they are here. Now, this site survey does not tell the whole story. This is an RF company that's been doing this. They're a great company, but their site survey's got some major flaws or issues. I show you this one because earlier I showed you the 2 slides showing the linear non-reflective propagation inside the big 20,000 square foot, and I showed you the little hotel where that thing was just completely striated throughout. It was completely deflected and attenuated in that little 7,800 square foot area. If you look at how linear this propagation is going throughout here, it's nice and smooth. What they did is they used a site IV Wave software. They modeled the outside wall of the building, and they said, hey, my signal strength is coming from this area. I can tell red and red. My tower's sitting back over here. They never modeled the interior of the building. So therefore, it's theoretically incorrect to say, hey, this is what's actually going on. These areas here that they're claiming that they're passing, they may only pass right here. But how bad this is truly over here, we don't know. Okay, we can tell immediately that they did not model the entirety of the building. It looks great, it looks fancy. But what they're saying here is, hey, look, these areas pass, but everything else 100% fails. Well, that's not the correct way to do that. It may fail, but we want to know what the signal strength is. Because if you have to have a BDA installed, we need to design it accordingly. We don't want to just say, hey, this whole area fails, worst case scenario, so you need to have 8 amplifiers to cover this building. When in actuality, if they modeled it correctly, you may only need 2 amplifiers for that building. And this is what it should have looked like. If you're going to model a building for a site survey, this is what it should look like. And how do we do that? We would say, okay, we've got a radio signal outside of here. This is what our signal strength is here. The predictive analytics software tells us this is what it's going to look like over here. This is what a heat map should look like, not that. This site survey here, this was sent to me. This one's quite interesting. These are things we want to look for. Look at these 2 corners right here. We have a negative 109 reading, negative 76. But FYI, we've already learned that, hey, what's on the outside of the building is theoretically impossible for it to be the same on inside of the building, okay? The signal strength, the only time it would ever be greater is if we had a BDA. And I know there's no BDA in this school. This is in Texas. They have a 109, we have a negative 39. Negative 39. Okay, that signal strength, guys, I have a nice receding hairline. That's because I've stand too close to too many radio amplifiers. That is going to make the hair curl off of your head, a negative 39. Negative 58, but it's theoretically impossible unless there's a BDA in here. They had the wrong frequencies in their radios. They didn't know what they were doing, okay? They also call it DAQ. Now, DAQ is a means of saying, hey, can you hear me now? And you grade that. So this is what you guys want to not be producing, or if you get something like this, you should see a decreased signal strength from the greatest area. So if I had neg 76, you're probably going to be sitting like in a neg 86, and it's going to diminish further throughout that building. The only way it would get greater is if an opening in the building was opened up, or we had a completely like atrium area right here, and it was able to go through this atrium area. or you had a BDA. I don't need that one. These are the code required for inbound and outbound signal strength, and we've got about 8 minutes left or 7 minutes left, so I kind of want to open this up. But here, this last slide we'll do is just the code required inbound signal and outbound signal strength. Guys, again, it's extremely important that we understand the signal strength coming in. It needs to be strong enough to create or deliver a DAQ level of 3 or greater, but we then also got to have adequate signal strength to get out of the building. Okay? The reality of it is, to achieve a -95 outbound signal strength, my incoming signal strength needs to be about a -82. Just because I'm trying to communicate on a small little radio versus a big tower. Okay? So let me open it up for questions. We got questions from anybody?
Yes, I have a question about existing buildings, going back to the
Yes.
beginning. We have a large campus where we had an existing remodel, and the contractor started asking, well, do we need to do any work with the DAS system? And reading the code, I see the same codes you brought up. There doesn't seem to be anything that instigates the need for BAS, but are we required to go have the contractor check in with the AHJ, or what's the process in an existing building project?
Well, so the code does dictate that all existing buildings shall have a minimum signal strength reading done in all of them already. So that's IFC section 1110. You'll find that initially initiated in 5.2 or 510.2.
So they should already be complying to that.
Yes.
Which is why
Correct.
I kind of say that the new project doesn't really instigate anything new.
So when we do fire alarm, fire sprinklers, or anything like that, that's automatically instigated, correct? Because we've got to see if we're changing the layout, changing walls, we got to adjust the fire sprinkler system, stuff like that. The code currently, you are correct, does not call anything out in the remodel section or anything along that lines. It is going to be, but right now it is not being called out. So it's, if you're from the A&E side of it, I would have a CYA just to go back to them and say, hey, look, this is in the code. You're not asking for this right now. If the AHJ comes back, we want to let you know that we recommend you do this. But again, it's your choice at this time because they're not enforcing it. It's in the code, though. That's the biggest thing. It's in there.
Mm-hmm. Mm-hmm.
If they choose not to do it, that's on them.
Okay.
It's unfortunately, that's one of those gray area questions we get asked a lot.
You're saying that that's going to be in a future code?
Yes, it is. It's going to be. You're also going to see, like, I want to say Oregon did an addendum to their code. They put an exemption of 50,000 square feet or greater. So you're keep an eye out for that also. We're seeing 12,000 and some up to 50,000 as an exemption also.
Okay. Thank you.
No problem. Any other questions?
Yeah, I have one. Is BDA the overall correct terminology for the entire system versus DAS?
So BDA
Like in our,
is the. Mm-hmm.
Just like in our specifications, we say DAS system versus BDA. Isn't DAS a part of BDA then?
Yes, it is. It is. There's also DAS is also being used as distributed amplifier system also. So when they use a fiber DAS system, but yes, it is two parts. So if in your specification, I would use the terminology ERCES, Emergency Responders Communication Enhancement System, because that then the components of the system being the BDA and the DAS will make that up for you.
Okay, thank you.
Mm-hmm.
I just wanted to point out that we can send out some specifications and some sample templates that will help you guys when you're designing these. I have that. I can send that out, and then Absco can send it out to the group.
Yeah, that'd be great. We have a pretty bare bones spec.
Perfect. Anything else for JP? Got a couple minutes? Again, oh, Tom, you're on mute.
It looks like that is about it. 1 minute early. Fantastic. Yeah, Dan, thank you for sending that spec out. We will distribute that to the group once we receive it. Just want to thank everybody again. JP, thank you for all your knowledge and sharing that with the group. Liz and Jen, thank you for setting up this webinar. Just a friendly reminder, anybody looking for CEU credits, please reach out with your contact information, obviously, and we will get you set up with CEU credits. Other than that, I hope everybody makes it a great day, and we'll talk and see everyone soon. Thank you.
All right. Thank you.
Bye.
Thanks, Tom.